Hi students, then we have to discuss the versatile nature of carbon. We discussed that there are a lot of number of carbon compounds that exist in our world. It includes the compounds produced by a living organism. Most carbon compounds are formed in living things. Why there are a lot of compounds by using carbon? What are the properties of carbon to form a huge number of compounds? That is the question. It's an important question. The first answer is catenation property. It is also a separate question. What is catenation property of carbon? Carbon has a unique ability to form its compounds with other atoms of carbon. Catenation property means self-linking property. A carbon molecule can link with other carbon molecule. That is the catenation property. Carbon has the unique ability to form bonds with other atoms of carbon. That is self-linking property, and this is called the catenation property of carbon. That is the first reason for the huge number of carbon compounds. Okay, then second one, tetravalency. Tetravalency of carbon atom. Carbon has a valency of 4. The valency of carbon is 4. That property is called tetravalency. Okay, then small size. Compared to silicon or other compounds in the group of carbon, it is smaller size. Then ability to form multiple bonds. Single bond, double bond, triple bond can form by using carbon molecules. Then strong CC bond. The carbon-carbon bond is strong. These reasons helps to make huge number of carbon compounds in our nature. Okay. Then this property, tetravalency. In our periodic table, there is a group for carbon. Carbon, silicon, germanium, tin, lead. These elements are tetravalent. The other elements cannot make huge number of compounds by using this tetravalency property, because carbon is smaller in size. Silicon is also smaller, but compared to carbon, silicon is larger in size. That is why this silicon can only make a few number of compounds. So this is the question. Silicon has tetravalency. Silicon and also germanium, tin, lead also tetravalent, but it does not form large number of compounds like carbon. Why? This is also an important question. The reason is that the size of the atom of silicon is larger than carbon. Carbon can hold the sharp pair of electrons strongly with the nucleus because of that smaller size, but silicon does not have the ability to bond strongly the electrons with the nucleus. So silicon forms only a few compounds. Silicon only forms few compounds. Then we have to discuss the saturated and unsaturated compounds of carbon. Saturated and unsaturated carbon compounds. In the previous class, we studied about single bond, double bond, and a triple bond. We also studied some examples for this single, double, and triple bond. Then, what is saturated and what is unsaturated compounds? We have to remind the single, double, and triple bond. Carbon atoms can form single, double, or triple bonds. Compounds of carbon atom which are linked by only single bonds between the carbon atoms are called saturated compounds. What are saturated compounds? The compounds in which there is only single bond. Okay, compounds of carbon which are linked by only single bond between these carbon atoms. We have to discuss the example in this question. Before that, what is unsaturated compound? Compounds of carbon having double or triple bonds between the carbon atoms are called unsaturated compounds. If a compound of carbon atoms contain double bond or triple bond, then we can say that that compound is an unsaturated compound. Let us check some examples. Draw the structure of methane, ethane and propane. Just listen here. First we draw the structure of methane. This ANE. We will discuss what is methane, what is ethane and what is propane. First, these all compounds contain ANE. ANE. This ANE represents the single bond and it is saturated compound. These examples are saturated examples for saturated compounds. Okay, let us draw methane. Meth. The first four letters meth means 1. This ETH, it means 2. Then prop means 3. So this element, this compound contain only one carbon atom. This compound contain 2 carbon atoms. This compound contain 3 carbon atoms. Okay, you have to study these things. It will help you to name this compound. Okay, we will discuss it later. Methane, it contains only one carbon atom. So I draw that single carbon atom and it is the outermost shell. We can represent the atoms. How many atoms are there in the outermost shell of carbon atom? There are 4 electrons. Carbon is tetravalent. So 4 electrons in the outermost shell of carbon atom. That is I drawn here. Then methane, it includes 4 other hydrogen atoms. I drawing this hydrogen atom here and also I mark the electron of the hydrogen atom by using a dot structure. The electrons of carbon is represented by a cross and the electrons of hydrogen is representing a dot structure. Okay, it is hydrogen and the electron. There is another hydrogen and the electron. There is another hydrogen and it is the electron. This is a covalent bond. This hydrogen and the carbon atom share their electrons. So how many carbon atoms are there in this compound? Only one carbon atom. So C1. C1. How many hydrogen atoms? H4. 4 hydrogen atoms. CH4. C1 is need not to be represent 1. Okay. If you didn't write anything, it also 1. So CH4 is the chemical formula of methane. Okay, it is methane. CH4 is methane. You can represent methane by using this molecular formula or chemical formula, and this is the dot structure of methane. This is the dot structure of methane. It contains 4 hydrogen atom and single carbon atom. Is this carbon atoms make the octet complete? 1, 2, 3, 4, 5, 6, 7, 8 is complete. So this compound is stable. This compound is a stable compound of carbon. Then let us draw the ethane. It means 2. So it contains 2 carbon atoms. It contains two carbon atom and I drawing this structure. It is the structure, and this carbon atom have this carbon atom has 4 electrons in the outermost shell, and also this carbon atom has 4 electrons in the outermost shell. So 1 2 3 4, 1 2 3 4. Okay, so it is a single bond. Then we have to draw the hydrogen atoms here, 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 then here also, here also, here. Is the compound stable? Yes, because 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. It is stable. You can. It is the dot structure of ethane. And what is the chemical formula? Chemical formula C. How many carbon atoms? 2 carbon atoms. C2. C2. Then hydrogen. H. How many hydrogens? 1 2 3 4 5 6. C2H6 is the chemical formula of ethane. This is the chemical formula of ethane. Then we have to draw the dot structure of propane. Prop means 3 carbon atoms. Okay, prop means 3 carbon atoms. So we have to draw the 3 carbon molecules. So we can draw these 3 carbon atoms and 1 2 3 4. It is the electrons in the valence shell of carbon, and this carbon 1 2 3 4, this carbon 1 2 3 4, complete. So it is single bond. It is single bond. Single bond means saturated compound. So it is saturated. It is saturated. It also a saturated compound. I have to draw the hydrogen atoms here, here, here. So this central carbon atom has only 2 hydrogen atoms. Okay, others 3. What is the molecular formula or chemical formula? How many carbon atoms? 3. C3. How many hydrogen? 1 2 3 4 5 6 7 8. CH8 is the chemical formula of propane. Okay, propane. We have to draw the structure of ethane, methane, propane. I think you get the idea. It's simple. You only need to focus the number of electrons. Total number of electrons 8. Total number of electrons 8. Total number of electrons will be 8 after the formation of these compounds. After the formation of these bonds. These are single bond. So the definition of single bond, saturated compound, contains only single bonds. Is there any double bond here? These 3 compounds contain only single bonds. So these 3 compounds are saturated compounds. Okay, these compounds are saturated compounds. Okay, these are saturated compounds. Then let us draw the other structure. Okay, then our next question, draw the structure of ethene and ethine. In this question, in the previous question we discussed methane, ethane, propane. In these three compounds, there is only a slight change. This ANE stands for single bond. This is ENE, ethene stands for double bond, and ethane, YNE, this YNE, it is for triple bond. Okay, read the question and find whether this is ANE, ENE or YNE. If it is ANE, then we can understand that these are single bonded compounds. This ENE represents this compound is a double bonded structure. This YNE means this compound is a triple bonded structure. So in the previous section we discussed about these three compounds and the structure. Then ethene. Eth means means 2. This also 2. So this compound contains 2 carbon atoms. 1, 2. Then draw this structure. How many carbon atoms? 2. And this ENE means there is a double bond in between these carbon atoms. Double bond. Okay. So here the 4 electrons, there is only 4 electrons in this carbon atom. So 1, 2, 3, 4. 1, 2, 3, 4. Okay. Then this carbon atom. 1, 2, 3, 4. So it is double bond. This double bond. That is this ENE indicates. Okay. Then there is another hydrogen atom. Fill the other electrons with the other hydrogen atom. Okay. It's enough. This is the complete structure. You can draw this hydrogen and this hydrogen in a simple manner, and there is a similarity. It is here and it is here. Then this should be, it is not much important, but you can draw this is in a similar manner. Okay. This is ethane. What is the chemical formula? How many carbon atoms? 1, 2. C2, 1, 2, 3, 4. H4. C2H4 is the chemical formula of ethene. Ethene or ethene. Okay, ethene. Then you can also draw the structure like this. C double bond C H2 or H. This is same as that of this. It is the dot structure and it is the symbol representation. It is the dot structure of ethene and it is the symbol representation of the structure. Then next one, ethine, YNE. YNE. How many carbon atoms? That's only it. So 2 carbon atoms only. 2 carbon atoms only. So C, draw the structure. YNE means there is a triple bond in between these 2 carbon atoms. So first mark the 3 electrons here and the 1 electron here. So it is complete. Then this carbon atom 1, 2, 3, 4. These are complete. So how many bonds? 1, 2, 3. Triple bond. then fill with hydrogen atom. It is ethane. What is the chemical formula? C2H2. C2H2 is ethene. C2H2 is ethane. Okay, YNE, ethane. It is C triple bond C H. It is your CH. Similar. CH triple bond CH. This can also draw like this. CH. So this valence electron can also get from this C 1, 2, 3, 4. Valency 1, 2, 3, 4. This carbon atom 1, 2, 3, 4. This hydrogen atom 1. So it is saturated. It is these two compounds are examples for unsaturated compound because it contains double or triple bond. Okay. It is the way of drawing the structure of saturated and unsaturated compounds. Okay. Okay, let us study more about the structure of carbon compounds. It is the basic concept. You have to study the naming as the basic. You have to count the number of carbon atoms in a compound and give the appropriate name. If there is only one carbon atom in that compound, then the name should be include meth. Okay, meth. First you have to rub these all ANE. I rub these all ANE from this order. So 1 meth, 2 eth, meth, eth, propobutylpendihex, you have to study in this way. Meth, eth, propobutylpendihex, okay. So you have to study these names in this order. It will help you to draw the structure and also to understand the structure and also to name the structure. So first 1 meth, 2 eth, 3 prop, 4 but, 5 pent, 6 hex, 7 hep, 8 oct, 9 non, 10 dec. If these compounds are ANE, that means it only includes single bond. If it is single bonded compound or saturated compound, then I can add this ANE into this whole name. ANE. Then methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. These are saturated compounds. Examples for saturated compounds. First, we have to draw these all compounds in a simple way. Here, not needed the dot structure. This simple structure. Meth means only one carbon atom. And what is the valency of carbon? 4. So, add 4 carbon atom. Because the whole valency is filled by these 4 hydrogen atoms. Then the second one, ethane. How many carbon atoms? 2 carbon atoms. Then ANE means only single bond, So I draw a single bond in between these two carbon atoms. Then how many other valence electrons are free here? One electron is bonded with these two carbon atoms. So here one, okay. Here one, here one. And how many left? 3. So 1, 2, 3. 1, 2, 3. These are filled. How many bonds? 1, 2, 3, 4. It is for this carbon. 1, 2, 3, 4 is for this carbon. Saturated. Okay. You can also draw it is CH3 single bond CH3. Okay. It is the simple representation. CH3 CH3. How you can draw this structure? CH H H. This is CH4. Okay. Next one. Propane. Propane means how many carbon atoms? 1, 2, 3. Prop means 3. 3 carbon atoms. ANE means only single bonds. Only single bonds. Here. Single bonds. Then how many electrons are left here? 1 is bonded. Then other 3. Okay. In this central carbon atom, 1 is bonded here. 1 is bonded here. How many left? 2. So you can rub this and CH2. CH2. 1 is here, 1 is here. And how many left? 2. So add 2 hydrogen atoms. And for this, there is 1 is here, then 3 is left. So CH3. CH3, CH2, CH3 is the chemical formula of propane. Okay, you need only to draw like this, a simple way. Then next one, butane. But means 4. 1, 2, 3, 4. Then fill the bonds. Okay. ANE means only single bond. Then how many left here? It's 3. 1 is here and 3 hydrogen. 1 is here and 1 is here, then 2. 1 is here, 1 is here, 2. 1 is here only. There is no here, so CH3. CH3, CH2, CH2, CH3 is the representation of butane. So let us check these two examples and found that there is only 3 hydrogen atom at the ends for ANE, for saturated compounds. 3, 2, 3. 3, 2, 2, 3. At the ends, 3 hydrogen atoms needed. Okay, next one. Pentane. Pent means 5. 1, 2, 3, 4, 5. ANA. Only single bond. Only single bond. Then fill the other valency. 1 is here. H3. 1 and 1. 2. But left 2. 1, 2. 2 left. 1, 2. 2 left. 1 only. So CH3. CH3, CH2, 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 CH3 is the representation of pentane. Next one. Hexane. Hex means 6. 1, 2, 3, 4, 5, 6. Any. 1 only single bond. Fill the other valency. Only 1 here, 3 left. 1 and 1, 2, 2 left. 1, 1, 2 left. 1, 1, 2 left. 1, 1, 2 left. There is only one here. CH3, CH2, 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 CH3 is a representation of hexane. Then heptane. Hept means 7. 1, 2, 3, 4, 5, 6, 7. Any. Only single one. Fill the other. One is here. H3. 1, 1, 2 left. 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 1 only. There is no here. This is heptane. Then octane. Octane means 8. 1, 2, 3, 4, 5, 6, 7, 8. Then any. Any. Single one, single one, single one, single one, single one, single one. Fill the other valency. 1 is here, H3 left. 1, 1, 2 left. 1, 1, 2 left. 1, 1, 2 left. 1, 1, 2 left. 2 left. 2 left. Then 3 left. CH3. This is octane. Then 9. 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Any single one. Single one, single one, single one. Then fill the other ones. 1 is here. It's 3 left. It's 3 left. 2, 2, 2, 2, 2, 2, 2, 3. This is none. Then decane. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Single one. Any single one. Fill the other valence. H3, H2, 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 H3. This is decane. So you can draw any structure in this way. It is the simple representation. You can extend this into dot structure by drawing that bulk structure. Very simple. You need to study in this way to write it for your exam. If the question is specified to draw the dot structure, then you should draw in the way that I draw in the previous example. Okay, now another question. What are isomers? What is structural isomerism? What is structural isomerism? It's a new concept, and listen here. Carbon compounds show identical molecular formula or chemical formula, but different structural formula are called structural isomers. There are plenty of carbon compounds are available. We studied to represent a structure into its molecular formula or chemical formula. The name is molecular formula. Let us take an example. Butane. What is the structure of butane? And how many carbon atoms? 4 carbon atoms are there in the butane. Let us draw butane. Butane, ANA. Butane. ANA means single bond, and left 3, 2, 2, 3. CH3, CH2, CH2, CH is the structure of butane. What is the molecular formula? How many carbon atoms? 4. 1, 2, 3, 4. How many hydrogen atoms? 3, 5, 7, 8, 9, 10. C4H10 is the molecular formula of butane. But by using this molecular formula, we can draw another structure. C4, 1, 2, 3, 4. I take this carbon atom and place it here. Is there any change? It is a new compound. It is another compound. But the chemical formula or molecular formula is C4H10. We have to fill the valency. One is here, then 3 left. 1, 2, 3 is here for this carbon atom. There is only 1 is left. So 1. Then it is only 1, then CH3, 1, CH3. It is the complete structure of this molecule, this compound. And what is the chemical formula, what is the molecular formula of this structure? How many carbon atoms? C4. How many hydrogen atoms? 3, 6, then 9, 10. C4H10. It is same as that of butane. So this compound and butane have same molecular formula but different structure. Which is the longest chain? It is the longest chain. And it only forms this chain. It is a branch. It is branch to this chain. This is another compound. But the chemical formula, the molecular formula is same as that of this. So our definition. Carbon compounds show identical molecular formula. Same molecular formula. But different structures. It is different structure. So these two are called structural isomers of butane. These two are structural isomers. Okay, I think you get the idea. Same molecular formula but different structural formula. Okay, that is structural isomers. Can you draw this compound with another way? This compound with another way. 1, 2, 3, 4. This same as that of this. Because I change only this branch to here. That is not a change because which is the longest chain here? 1, 2, 3. Carbon. Number the carbon. 1, 2, 3. Here 1, 2, 3, 4. This and this are same because 1, 2, 3. Number this carbon atom in starting from anywhere. So 1, 2, 3. And there is a branch from 2. There is a branch from 2 carbon atom in this branch, in this chain. The same thing will repeat here. 1, 2, 3. This is the chain, and there is a branch at the second carbon. It is same here. So these two are same. Not the structural isomers. This is equal. These are equal, but these are not equal. These are structural isomers. There is a difference. You have to note it. These are structural isomers, but this is same. This is equal, same. So need not to be right. These two are in structural isomers. These are same. So you need not to draw like this. The same. These two are in structural isomers. Then there is one question. Draw the structural isomers of hexane. Hexane means hex 6 electrons, 6 carbon atoms. 6 carbon atoms. Any means single bond. Then fill the other valency. 3, 2, 2, 2, 2, 3. CH2, 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 CH2. Draw the other structural isomers. So there is 6 carbon atoms. 1, 2, 3, 4, 5, 6 So draw by using the 5 carbon atom, 5, and make this one carbon atom as a chain in the second carbon atom. This is one isomer, and fill the other valence CH3, CH2, CH2. Then here there is 3 electrons. See, 3 bonds are connected to this carbon atom. So 3 are connected and one only left. CH here, CH3, CH. This is one structural isomers of hexane. Then there is one more isomers. First, we draw this branch in this second carbon. Then we move to the third carbon. 1, 2, 3, 4, 5, 6. Here the molecular formula. 1, 2, 3, 4, 5, 6. C6. Then how many hydrogen atoms? 3, 5, then 7, 9, 11, 12, 13, 14. Okay, 40. Here, in this case, the molecular formula C6. 1, 2, 3, 4, 5, 6. H 7, 8, 9, 10, 11, 12, 13, 14. So, same molecular formula but different structure. This is structural isomers. And then one more 1, 2, 3, 4, 5, 6. 6 carbon atoms. C6 and ANE single bond. And fill the other valency CH3, CH2, C1, 2, 3. Only one is left. Then CH3, 1, 2, CH2, CH3. So fill this hydrogen atom properly. Okay. Count the valency of this carbon atom. One is bonded with this carbon atom. So draw other 3. Then it is bonded with 2, then other 2. It is bonded with 3, then only one is left. Then 1, 2, 3. Here only 1, 3. Here only 1, 3. So that is the way you should add this hydrogen atom properly, otherwise it will not get the correct molecular formula. So think about it. How many hydrogen atoms? 5, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Same molecular formula but different structure. These 3 are the structural isomers of hexane. Okay. Then you can make this branch into here, but it is same as that of this. So that is not a structural isomers. These 3 are structural isomers.